have done union and we have done intersection. Now we'll do complement of A. So let's come back to the board. We'll do complement of A. The complement of a set, let this be the universal set and A be the subset. A be the subset. So subset. Every set is a subset of itself. Every set is a subset of itself. The set of elements outside of A is termed as complementary set of A. This is denoted by A dash or A C. This is the complementary set of A. So mathematically we can write A dash or A prime or complement of A equal to universal set difference of A. Universal set difference of A. In set we cannot say minus, we will say difference. Okay, be careful. That means A will be outside of universal set. A will be the outside of universal set. Let's come back to example. Here is universal set equal to A, B, C and D, and set of A equal to B and C. Then complement of A or A dash equal to, at first you have to write given universal set and A. So mathematical rules, complement of A, that means or A dash equal to universal set difference of A. If you can say here is B dash or B prime, we have to write universal set difference of B. So what is the element of universal set is, you can see A, B, C, D. Then difference, and here is A, here is B and C. So this is the outside. You can see a language outside of A. So B, here is B and C, just outside. B and C out from here. So we will get complement of A equal to B and C out. So we get A and D. This is the answer. So we have got complement of A. Let's come back to the board. We will do some example about complement related. Please come back to the board. We have done union and intersection, and we have learned the complement of A, and we have got the rules mathematically. Now we will have to prove that. You can see if universal set equal to 1, 2, 3, 4, 5, 6, 7 and A equal 1, 2, 5, B equal 2, 4, 7. So prove that this side equal to this side. A intersection B complement equal to complement of A union complement of B. Let's come back. At first you have to write given part. So here is universal set equal to 1, 2, 3, 4, 5, 6 and 7. A equal this and B equal this. You can say here is A intersection B complement. So at first you have to find out A intersection of B. Then you have to find out A intersection B complement. Let's come back. A intersection B. A intersection of B. A intersection B. This is A, this is B. So intersection means common. So here is common is only 2. So we have got intersection A intersection of B. Now we have to find out the left hand side. So A intersection B complement equal to universal set difference of A intersection B. So you have to write the universal set at first. Here is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. And A intersection B here is 2. So we have learned the rules. If a dash or complement of a, if we have to find out the complement of a, the mathematically we can write universal set difference of a, universal set difference of a. We cannot say minus, universal set difference of a. So in the same way, a intersection b, that means universal set difference of a intersection b, universal set difference of a intersection b. So universal set and difference and a intersection b here is 2. You have to outside, keep it outside. Here is 2. So here is, you can see here is 2. So we get left hand side 1, 3, 4, 5, 6, 7. So we have got left hand side. Now we have to find out right hand side. For right hand side, here is 3 parts. You can see at first you have to find out complement of A and complement of B. Then you have to find out complement of A union complement of B. Be careful. So let's come back. Here is. So here is at first you have to find out complement of A. Again, complement of A equal to universal set difference of A. So universal set equal to 1, 2, 3, 4, 5, 6, 7. So write 1, 2, 3, 4, 5, 6, 7. Then here is A equal to 1, 2, 5. A is 1, 2 and 5. 1, 2 and 5. So here is 1, 2, 5. 1, 1, 2, 2 and 5. 1, 2, 5. So if you can say this type of maths, use pencil. Otherwise element with left. So you have to use pencil. Then if you start, it will easy for you. So 1, 1 out, 2, 2 out, 3, 4. We get 3, 4, 3, 4 and 6 and 7. So we have got complement of A. In the same way, you have to find out complement of B. So complement of B equal to, you have to write universal set difference of B. So universal set here is given is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6 and 7. Difference of B equal to 2, 4, 7. Right? 2, 4, 7. So we have got here is 2, 4, 7. Be careful. Here is 2 and 2. Here is 4, 4. Here is 7. Here is 7. So we have got here is 1. Then 3. Then we have got 5. We have got here is 6. Be careful. When you solve this type of maths, use pencil. It is easier for you. Now, already we have done the left hand side. Now, right hand side. You have to find out right hand side. So, for right hand side, you have to write right hand side equal to complement of A union complement of B. Let's come back to right hand side. Complement of A union complement of B. We have got complement of A equal to complement of A and complement of B. Complement of A and complement of B. Complement of A equal to, we have got here is 3, 4, 6 and 7. Union, here is complement of B equal to 1, 3, 5 and 6. So we have got union means common and uncommon. Common and uncommon. 1, 3. Write serially 1, 3, 4, 5, 6 and 7. So left hand side and right hand side are same. Therefore, we can write left hand side equal to right hand side. Here is proof that. For this reason, you have to write proof. Okay? We learned now subset, then factors, then prime factors, and then we will start our maths. So please follow the board, and you can say here is a subset equal to what is called subset. We have to know definition of subset, and already we have learned the complement. Okay, let's come back to the board. You can say here is subset equal to any set A is said to be a subset of B if every element of A are also element of B. It is denoted by this. So example, you can see here is an example: A equal 1, 5 and 7 and B equal 1, 3, 5, 6 and 7. Then we can write A subset of B. A is a subset of B. Any set A is said to be a subset of B if every element of A are also element of B, because every element of A belongs to B. Every element, you can see 1, 5 and 7. Here is 1, 3, 5, 6, 7, because here is 1, 5 and 7. Here is, you can see here is 1, here is 5 and here is 7. For this reason we can say A is a subset of B. Okay, let's come back. It's the important part. Every set is a subset of itself. And null set or empty set is a subset of every set. The rules of subset is 2 to the power n. Here n is the number of elements. Okay, every set is a subset of itself. And you can say empty set is a subset of every set. Okay, let's an example here is, you can see A, B, C. Then subset of A will be. When we write the subset, here is number of element is 3. So at first every set is a subset of itself. For this reason I have written A, B, C at first. Then we will follow the method of 3, 2, 1. That means at first we will take here is 3 elements. For this I have taken here is 3 elements A, B, C. Every set is a subset of itself. Then what I say, 3, 2, 1. This is not the actual rules, but if we want to break the maths easily, so we can remember, if element is 3, then it will break 3, 2, 1. And if element is 4, then 4, 3, 2 and 1. Okay, now here is 3 element. Here is 3. You can say here is 3 element A, B and C. So 3, 1, 2, A, B, C. Here is A, B, B, C, A, C. A, B and C. And here is empty set. So we have got the subset. Then factors. Because when we start maths, then we can see the factors, we can see the prime factors, then natural number, it will come. Okay, let's come back. Factors, each of the numbers which participate in the making the product is called the factor of the product. Here is, you can see 10 equal to 2 into 5, because therefore 2 and 5 are the factors of 10. 2 and 5 are the factors of 10. Now we have to know the prime factors. Already we know what is called prime number, the number which is divisible by only one and itself. The number which is divisible by only one and itself is called a prime number. Okay, let's come back. What is called the prime factors. Prime factors. All the factors of a number which are prime numbers are called the prime factors. You can see an important example. So if we break 30, we will get 2 into 15. 2 into 15 equal to 30. And if we break 15, we will get 3 into 5. So here is 2, here is we have got 3 and 5. Therefore, 2, 3 and 5 are the prime factors of 30. Now we will have to know the multiples, we will have to know natural numbers, we will have to know integer, then we will start our new maths. Okay, let's come back. We will know the what is called the multiples. You can see here the multiples. When two or more numbers are multiplied, the product is formed, called a multiple of the numbers. Here is, you can see 6 equal to 2 into 3. Therefore, 6 is the multiple of 2 and 3. 6 is the multiple of 2 and 3. So 10 equal to 2 into 5. Therefore, so 2 and 5 are the multiple of 10. The same way, already we have done the multiple. Now we have to know the integer. What is called integer? Consisting of whole valued positive number, negative number and 0. You have to be careful. Positive number, negative number, positive number, negative number and 0. Consisting of positive number, negative number and 0 all together are called integer number. Integer number is denoted by Z. Integer number denoted by Z. So you can say Z equal to, that is infinity. It's up to infinity. Minus 3, minus 2, minus 1, 0, 0, 1, 2, 3, dot, dot, up to infinity. This is the integer. When you solve the maths, you can see the integer number. For this reason, we have to know what is called integer number. Then natural number. What is called natural number? Any integer number greater than 0 is called a natural number. It is denoted by capital N. N equal to 1, 2, 3, 4, 5 dot dot up to the infinity. So any integer number greater than 0. You have to be careful. A natural number, that means it is denoted by N. Any integer number greater than 0. Any integer number greater than 0. And integer number, that means we have learned integer equal to consisting of whole valued positive number, negative number and 0. Integer means positive number, negative number and 0. But in natural number, any integer number greater than 0. Any integer number greater than 0 are called natural number, which is denoted by N. Now come back, another point, the real number. A set of real number consists of positive number, negative number and 0. Positive number, negative number and 0. You can see integer and real definition are same to same, but you have to be careful. The number except imaginary number are called real number. It is denoted by R. Okay, so up to the infinity, minus 4, 3, minus 2, minus 1, 0, 1, 2, 3, 4 dot dot up to infinity. I have told here one word is imaginary number. What is called imaginary number? So it's a imaginary number. You can see here is minus 2 then square root. Okay, this type of number are the imaginary number. Be careful. Okay, let's come back to the next math. Now we have to do some maths using tabular method and set builder method. Let's come back to the board. You can see here is express the following sets in tabular method. What is a tabular method? You have to find out the value in 1, 2, 3 using, that means using table. Now here is another word is x such that x is an odd number. X is an odd number. So we have to know what is called odd number. Odd number means the number which is not divisible by 2, which is not divisible by 2. Let's follow the numbers which are not divisible by 2. Example 1, 3, 5 and 7. You can got the rules n equal to 2k plus 1, where k is an integer. K is an integer. Odd number, the number which are not divisible by 2. So here is, you can say the condition, you can say here is a condition 3 which is less than x, and x also less than 15, x also less than 15. So here is odd number, here is odd number. So greater than 3, odd number will be 5, greater than 3, odd number will be 5. Therefore odd number will start from here. According to the condition, odd number will start from 5, because 3 is less than x, so that we cannot take 3. So 3, 5, so we have taken here is 5, then we have taken 7, then 9, then 11, then 13, because according to the condition x, values of x will be less than 15 and greater than 3, and another condition odd number, So what is called odd number? We have to know the numbers which are not divisible by 2, that's the odd number. So this math's done. Let's come back. We will do another maths. The maths is x is a prime number, prime factors of 48. X is the prime factors of 48. Let's come back to the board. B. X is the prime factors of 48. Please follow the board. You can see x is a prime factors of 48. Prime factors. Already we have learned the definition of prime factors. Okay. So at first you have to break 48. That's 24 to 12 to 6 to 3. Now prime factors, the factors which are prime. Already we know the definition, the number which is divisible by only one and itself. So here is 2, 2, 2, 2, 2. So we can take 1, 2. Here is 2 and 3. Okay. So we can write answer here only 2 and 3. These are the prime factors. Okay. Let's come back in maths number C. So already we have got prime factors and we have got odd numbers. Okay. Let's come back another maths. Maths number C. X is a 3 is a multiple type maths. Okay, which is less than 36. Let's come back to the board. You can see here is x such that x is a multiple of 3. X is a multiple of 3. So we have to know the table of 3. So here is you can see 3 into 1 we have got 3. 3 into 2 we have got 6. 3 into 3 9. 3 into 4 12. 3 into 5 15. 3 into 6 18. 3 into 7 21. 3 into 8 24. In the similar way we have got 3 into 12 36. 3 into 11 33. But according to the question you can see x is a multiple of 3. X is a multiple of 3 and x is less than 36. So at first you have to write table in your rough work, then we can easily got the maths. So you have to write now. Here is acceptable value is 3 6 9 12 15 18 21 24 27 30 33, but 36 is not acceptable according to the question. So you have to write here 3 6 9 12 15 18, 21, 24, then 27, 30 and 33. So according to the question, we have got the answer. So maths number C done. We will do another maths, integer type maths. So please come back to the board. We will do integer type maths. This is an important maths and you have to do the integer number less than 10. So already we have learned the definition. What is called integer number? What is called integer number? Positive number, negative number and 0 all together are integer number and it is denoted by Z. Integer number, that means whole number. So let's come back to the board. You can see here is express the following sets in tabular method, and x such that x is an integer number and x square less than 10. So z is the integer number, z equal -4, -3, -2, 1, 0, 1, 2, 3, 4 I have taken. Let's start. When x equal -4, we have got x square equal -4 whole square. This is 16 greater than 10. But here is condition is x square will be less than 10. So which doesn't you can say doesn't satisfy the condition. So we cannot take x equal -4. Let's another. Here is x equal -3. I have taken -3. We have got 3 square equal 9 less than 10, which satisfy the condition. For this we can take it. We can take -3. The similar way, x equal -2, x square we have got 4 less than 2. So this is also acceptable. So it is satisfy the condition. And x equal -1, x square we have got 1 less than 10. So this is also acceptable. That means satisfy the condition. So what is the condition of the integer number? Positive number, negative number and 0. Positive number, negative number and 0. So here is 0. So 0 square equals 0 less than 10. So this is also satisfy the condition. In a similar way, x equal 1, we have got 1 less than 10. This is satisfy the condition. X equal 2, we have got 4 less than 10. So this is satisfy the condition. And x equal 3, we have got 9 less than 10. This is satisfy the condition. And x equal 4, according to the question, we have to take up to 4. So here is 4, x square equal 4 square, 16 greater than 10. This is not satisfy the condition. So this is not the satisfy the condition. So in tabular method, we have to write only the satisfied which number satisfy. Okay, so please come back here. After completing this, we can write answer in this way. At first you have to complete the full task, then you have to write answer. So please come back. You can see here is after completing this, please come back. Please come back here. Here we can write answer. That means which is satisfied the condition. Satisfied the condition is here is, you can see here is x equal -3, x equal -3, -3, -2, -1, 0, 1, 2 and 3. These are the acceptable. That means this and this are satisfy the condition. So we have done the maths. Please come back. We will do another maths. Already we have done express in tabular method. Now we will have to know express in set builder method. This is very easy. Just you have to follow the condition. You can see here is 3, 4, 5, 6, 7 and 8. Express in set builder. Here is 3, 4, 5, 6, 7 and 8. These are the natural number. Just you have to use the condition. Here is 3. That means 3 is greater than 2. 3 is greater than 2. but here is 9, yeah, 8. So 8 is less than 9. So let's come back to the board. We can write 2 less than x less than 9. So we have got the answer, because here is, this is 2, that means here is 3, 4, 5, 6, 7 and 8. So 8 is less than 9, 8 is less than 9, and 3 is greater than 2, 3 is greater than 2. So this is the condition we have got. Let's come back in another maths. You can see here is 4, 8, 12, 16, 20 and 24. So if we multiply 4 by 1, then we get 4 into 1, 4, 4 into 2, 8, 4 into 3, 12, 4 into 4, 16. So in this way, for this reason, this is x is a multiple of 4, but here is 24, 4 into 6, 24, 4 into 7, 20. So we can write here is x is a multiple of 4 and x less than 28, So already we have done the tabular method and set builder method. Now we will do a Venn diagram. Already we have done set builder method and tabular method. Now we will solve the maths using Venn diagram. So we will have to know what is called Venn diagram. So let's come back to the board. What is called Venn diagram? So John Venn introduced the method of expressing the sets using diagram. John Venn used a Venn diagram for expressing set. The Venn diagram used by in the rectangular shape or circular shape. Okay, let's come back to the board. We will solve a small maths. Okay, let's come back. You can see here is a figure. You can see here is A, here is B, and here is C. So it is universal set. So let's find out here is how many elements. Here is 1, 2, 3, 4, 5, 6, 7 and 8. So this is universal set equal to, we have got 1, 2, 3, 4, 5, 6, 7 and 8. Let's find out A equal what. So in A we can see here is 1, 2, 3 and 4. So write A equal 1, 2, 3 and 4. So B equal what? So in circle B we can see 2, 3, 5 and 6. In B we can see 2, 3, 5 and 6. And C we can see 3, 4, 6, 7. 3, 4, 6 and 7. So according to the Venn diagram we have got A, B and C. So easily we can find out A intersection of B. So what is A, what is B? So you have to write first A equal 1, 2, 3 and 4. 1, 2, 3 and 4. And so right here 1, 2, 3 and 4 intersection. Here is B equal 2, 3, 5, 6. 2, 3, 5, 6. So intersection, already we all know intersection means common. So you can find out common terms. Here is common is 2 and 3. You can find out easily. Here is 2, here is 2, here is 3, here is 3. So we have got A intersection B equal to 2 and 3. We have got 2 and 3. So easily we can find out A union of B. So at first, according to the figure, we have to write A, then you have to write B. So let's come back. Here is A equal to 1, 2, 3 and 4 and B equal to 2, 3, 5 and 6. So union means common and uncommon. So let's come back to the board. Here is common is only already we have seen here is common is 2 and common is 3. This is the intersection. Now follow here A union of B, common and uncommon both. So here is 2, 1 is uncommon and common is 2, common is 3, then uncommon is 4, uncommon is 5, uncommon is 6. So we have got union and intersection using Venn diagram. So thank you all. So if you want to learn maths chronologically, then you have to follow all lectures, okay, and you have to follow all example and board question. This is very important for you. So stay home, stay safe. Thank you all. No more today.